Hello students, welcome to PK's Learning Station. Today we are going to discuss about nodal analysis. The last video also we discussed the nodal analysis, but that nodal analysis which contain only current sources. But now we are going to discuss nodal analysis which having a voltage source with a series of resistance. Okay, so first you have to identify the number of junction points. So as per this, the junction points are this 5 ohm, 10 ohm and 15 ohm connecting point as a junction A. 10 ohm, 8 ohm and 12 ohm is connecting junction as B. Then another junction as the bottom. So 4 volt, 15 ohm, 8 ohm, 6 volt. 4 ohm, 15 ohm, 8 ohm, 6 volt. All will be connected at the same time. This is the ground. Okay. The reference node. The reference node voltage is 0 volt. The voltage for node A we have to consider as VA. The voltage at node B is VB. The voltage at node A is VA. The voltage at node B is okay. So you have to find out. Then the question is to calculate the current flowing through various resistors. First you have to find out VA and VB. Based on the VA and VB, you have to find out the current flowing through the various resistors. Yes. So now we're going to apply the KCL for each node. So before going to the KCL, you have to assume the current at each resistor. So we have to assume as our own direction. I have to assume the current flowing through this 5 ohm resistances I1, the current flowing through 15 ohm resistances I2, current flowing through 10 ohm resistances I3, the current flowing through 8 ohm resistances I4, the current flowing through the 12 ohm resistances I5. Okay. So and then there should be voltage source is given. The voltage is connected between this ground to this node point. Yes, the this 4 volt is connected between this ground to this point. Then this point voltage is 4 volt. Similarly, the 6 volt is connected between the ground to this point. Okay, then here the voltage is 6 volt. Okay, now we are going to apply. We are going to apply KCL at node A. At node A. So what are the currents available in the node A? I1, I2, I3. Okay. So what is the KCL? Kirchhoff's current law. At a junction point, sum of the current entering is equal to sum of the current leaving. Sum of the current entering is equal to sum of the current leaving at a junction. What are the current entering here? The I1 is entering, I2, I3 are leaving. So the I1 current is entering. Yes, the current I1 is entering and I2 and I3 are leaving. Okay. So similarly for we have to find out what is I1, I2, I3, I4, I5. We have to find out those things first. Okay. We have to find out what is I1. What is I1? For I1 is nothing but current flowing through this 5 ohm resistance. So the starting voltage is 4 volt, right? So starting voltage minus end voltage divided by the resistance. So starting from 4 volt, 4 minus VA divided by 5. 4 minus VA divided by 5 times. This is for I1. What about your I2? I2 is connected between node A to ground. So the node A voltage is VA minus 0 divided by 15. VA minus 0 divided by 15 because the 15 ohm resistance is started at node A. The voltage at node A is VA and ending at ground voltage is 0 divided by the resistance. Similarly, what about our I3? The I3 is current flowing through the 10 ohm resistance. The current I3 is started at node A, voltage as VA, then end at node B, voltage VB. So VA minus VB divided by 10. VA minus VB divided by 10 amps. Next, I4. What is your I4? I4 is flowing through the 8 ohm resistor. So node B to 0. The node B voltage is VB minus 0 divided by 8. VB minus 0 divided by 8 amps. Divided by 8 amps. Next, we can go for I5. What is your I5? Current flowing through 12 ohm. So the I5 is started at point B. The voltage is VB minus end at 6 volt. So VB minus 6 divided by 12. VB minus 6. VB minus 6 divided by 12 amps. So now we're going to substitute those values here. We're going to substitute those values here, right? So what is your I1? You have to substitute those I1, I2, I3, I4, I5 values in this equation. So 4 minus VA divided by 5, which is equal to I2 is VA by 15 plus for I3 is VA minus VB by 10. Yes. What is the LCM here? So the LCM is, so here 3 and 5, 2 and 5, 6. So LCM is 30. We take LCM as 30. So this side we can keep 5 as it is. 4 minus VA, which is equal to 30 as a LCM. 30 means multiply with 2. 2 VA plus here 30 means we have to multiply with 3. 3 VA minus 3 VB. This 30 will go this side. We have to do the cross multiplications, right? So this 30 will come this side. What happened? So 30 into 4, 120 minus VA, not VA. 120 minus 30 VA. 120 minus 30 VA. So this 30 will be multiplied with 4. 4 3s are 1. So 30 will be 120. So 30 VA, which is equal to, so 2 5s are 10 VA plus 15 VA minus 15 VB. Finally, what happened? The equation, the final equation is, so I will bring this on this side. So I will move to this 30 VA on this side. Finally, what happened? Already here 25 VA. Here minus 30 will become a plus 30. So 25 plus 30, 55 VA. 55 VA minus 15 VB is equal to 120. Equation number 1. Then we have to go for applying KCL at node B. Apply KCL at node B. At node B. What is the node B? So this is the node B. What are the currents is? I3, I4, I5. Okay, I3, I4, I5. So now what happened? Your I3 is the incoming current, right? I3 is the current entry. I4 and I5 are leaving. So I3 is equal to I4 plus I5. Take your I3, I4, I5 and substitute here. Okay. Take your I3, I4, I5 and substitute that. What happened? Yes. So what happened now? What is I3? Or I3 is VA minus VB by 10, which is equal to, or I4 is VB minus 0 by 8 plus, or I5 is VB minus 6 divided by 12. Okay. So what is the LCM? Here 2, 4, here 3, 4. So 24, right? You have to take LCM as a 24. VA minus VB is equal to, LCM is 24. You have to multiply 3. 3 VB plus this will be multiplied with 2. 2 VB minus 2. Now we have to do the cross multiple. So 24 VA minus 24 VB, which is equal to, so here 3 plus 2, right? 5 VB totally. 50 VB minus 120. Now we have to bring this side and this side, right? You have to change this. So finally minus 24 VA plus 74 VB is equal to 120. Equation number 2. I will move this 120 on this side. So this will be this side. Okay. So this minus 24 will come. This side is plus 24. So this 74 VB. This 24 will come on this side is minus 24. This 120 will come on this side plus 120. Okay. Now we have two equations. What are the equations? The equation 1 is, so the equation 1 will be, so the equations are 55 VA minus 15 VB is equal to 120. Equation number 1. The next equation is minus 24 VA plus 74, right, plus 74 VB is equal to again 120. Equation number 2. So we can solve this equation 1 and 2. So solve this equation 1 and 2. We have to find out the answer. Yes, you can solve either by grammar rule or you can solve with the calculator equation mode. So I will solve by equation mode. So how many unknowns here? 2 unknowns. So 55 minus 15, 120. Next equation is minus 24. So plus 74, 120. So here the voltage V1 is nothing but, not V1, VA, right? VA is nothing but 2.88 volts. VB 2.56 volts. So if the question is as does the nodal analysis, then the nodal analysis, the first step is identify the number of nodes, find out the node voltages. That is the nodal analysis. Then after finding this VA and VB, whatever the question is asked, current flowing or voltage across, that you have to go as per the voltage values. Now we can go for finding the various current. So already we assumed the various currents I1, I2, I3, I4, I5. We have to substitute this I1, I2, I3, I4, I5. So all the calculated VA and VB values here, we'll get all those. What about your I1? 4 minus VA by 5. Your I1 is 4 minus VA by 5. 4 minus VA by 5. Yes. Your I1 is 4 minus VA by, yes, 4 minus VA by 5. 4 minus VA by 5. What is the value now? 4 minus, what about your VA? 2.88 divided by 5. What is your I1? Is 4 minus 2.88 divided by 5. It should be 0.224 amps. Next, I2. Your I2 is current flowing through 15 ohm resistor. VA by 15. VA minus 0 by 15. I2 is VA minus 0 by 15. So 2.88 divided by 15. So 2.88 divided by 15. So 0.192 amps. What about your I3? Your I3 is nothing but VA minus VB by 10. This 10 ohm current. VA minus VB by 10. 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 What about your VA? 2.88 minus VB is 2.56 divided by 10. So 2.88 minus 2.56 divided by 10. So 0.032 amps. Then the I4. What is your I4? Your I4 is nothing but current flowing through 8 ohm resistor. VB by 8. VB minus 0 by 8. 0 I can do it. VB by 8. VB by 8. So VB is 2.56 divided by 8. 2.56 divided by 8. So 0.32 amps. Then finally your I5. What is your I5? I5 is current flowing through 12 ohm. So VB minus 6 by 12. VB minus 6 by 12. Your I5 is VB minus 6 by 12. Your VB is 2.56 minus 6 divided by 12. So 2.56 minus 6, the value is coming in negative, right? It should be minus 0.287 amps. So the actual current should be flowing in opposite direction. Our assumed current direction is wrong. The actual current should flow from opposite direction. So you want to write one line from that. Okay. Yes. This is a normal nodal analysis using a KCL. Now, the same problem we are going to solve by matrix method. Okay, how to solve by matrix method? Already I told. If you are going to solve nodal analysis by matrix method, there should be a constraint. What are the constraints? So all the sources is current source. Then no problem. You can solve directly by matrix method. If there is a voltage source is present in your nodal analysis circuit, then there should be series with resistance. There should be series with resistance. Here, the voltage source is connected, but voltage source is having a series of resistance. So this voltage source also having a series of resistance. Then we can go by matrix method directly. Okay. So we can go for matrix method of this. Go by matrix method. Yes. The same number of nodes are similar, right? So same thing, right? Similarly, you are finding the two nodes. Node A, voltage is VA. Node B, voltage is VB, right? Node A and node B. The voltages for node A is VA. The voltage for node B is VB. Then ground node, reference node. Okay. Now what is the number of nodes? It should be two nodes. Then what is the structure of your matrix? 1 by R matrix into voltage matrix is equal to current. I is equal to V by R. Okay, the KCL only, right? So the 1 by R matrix should be a square matrix. It is depending upon the number of nodes or number of unknowns. There is a two unknowns, two nodes. So the size of 1 by R matrix is 2 cross 2. The voltage matrix is column matrix 2 cross 1. Current also is a column as a row column matrix 2 cross 1. Okay. Now we are going to form a matrix. So 2 cross 2 matrix. Voltage V1, V2, then current. Okay. The voltages are VA and VB. So what are the values will come here? Yes. So what happened here? So you have to take whatever the resistor is connected with the node, same resistor. What are the resistors connected with the node A? 5 ohm resistor is connected, 15 ohm is connected, 10 ohm is connected. So take a reciprocal of each and add. So for 5 it is 1 by 5, for 15 it is 1 by 15, for 10 it is 1 by 10. All you have to take a reciprocal and add. Similarly, what about second diagonal? Same. So 10 ohm, 8 ohm, 12 ohm. So 10 ohm 1 by 10, 8 ohm 1 by 8, for 12 ohm 1 by 12. Close the bracket. Next. So what is the off diagonal? Identify the resistance between the node. The node A and B, there is a 10 ohm resistance. So minus 1 by 10. Here also minus 1 by 10. Okay. So what are the current now? So currents are, so here there is no current, right? So you want to convert into a current first. So normally, if you're going into the practical voltage source or current source, the practical voltage source should be look like this. Voltage source series with resistance. the voltage source series with the source resistance. There should be internal resistance is available. This is the practical voltage source. Now, if you are converting the practical voltage to a practical current source or practical current source to practical voltage source, we can able to change. So normally, if there is a current source, the current source should have a internal resistance in parallel. The voltage source have internal resistance in series, but current source will have internal resistance in parallel. Remember, this is the practical current source. Current source IS having internal resistance or source resistance in parallel. This is the practical voltage source. The source value is Vs, voltage value is Vs, having internal resistance or source resistances Rs will be in series. Okay. Then how to convert the other quantities? So if you are going to find Vs, the same V is equal to IR, Is into Rs. If you're having a current source, if you're going to convert a voltage source, then what about your Vs? Is into Rs. V is equal to IR formula. You can substitute. Similarly, if you're going for voltage source to current source, the current source is nothing but I is equal to V by R. Vs divided by Rs. Remember this. We can convert vice versa. We can convert vice versa. We can convert voltage to current and current to voltage, but the resistor in voltage source is series, current source is parallel. Remember this. Okay. Now we are going to do the same thing here. We are going to do the same thing here, that we are having a voltage source series with resistance. So we can easily find out the current. The current is nothing but V by R amps. What is the current direction? The current direction is toward the positive direction. Your current flow should be towards positive direction. The current direction is toward the positive, where your positive is located, right? The current direction toward the positive. So your positive is upward. The current is flowing through the upward directions. So if the current is upward, what happens? Current is entering. The current is entering. If the current is entering, then plus 4 by 5. Similarly, for coming to this side, there is a 12 ohm and 6 volt will be in series. So I am going to convert a current source. The direction of the current source is upward because the positive polarity is upward. What is the current? I is equal to V by R. 6 by 12 amps. 6 by 12 amps. So this also current is entering to the node B. Entering means plus. Leaving means minus. So here the current is entering, so plus 6 by 12 amps. Now we can substitute in the matrix. You have to find out that VA and VB. You have to find out your VA and VB. Either the both we can use by matrix method, or you can use by grammar rule, or you can use by equation mode, anything, right? So I will solve by equation mode. So these are the A right? These are the coefficients of A. These are the coefficients of B. These are the coefficients of C. A1, B1, C1, A2, B2, C2. Okay. So what is your A1? A1 is 5 inverse plus 15 inverse plus 10 inverse. Then what about your B1 is minus 10 inverse. Then the current is 4 divided by 5. 4 divided by 5. Then here minus 10 inverse, and then 10 inverse plus 8 inverse plus 12 inverse, and then the voltage current is 6 divided by 12. So finally the VA is 2.88 volts. Then the VB is 2.56 volts. The remaining, finding the current flow in the various resistors are similar to this method. Once you are finding VA and VB, the I1, I2, I3, I4, I5 equations already we derived. The same procedure you have to follow it here also. Yes. Thank you for watching. If you have any comments, doubts, please put it in the comment. Okay. Thank you. Thank you for all.